Good day, dear MOW217 students. So this video is created to give you an overall understanding of the mechanical assembly that you are working towards with your practicum detailed mechanical drawings. Okay, the assembly you can see on the screen, I call it the Shigley Hauler gearbox, and I will get back to this screen and explain some of the details regarding the gearbox. Okay, the first question that you may have is, where does the name Shigley Hauler come from? Okay, and this name comes from the US, where two researchers, Faruqi and Link, in 2016 published this research paper on a Shigley Hauler competition that they launched at the University of California in Davis in the US. So what it basically does, Shigley, the name Shigley should ring a bell. We use Shigley's mechanical engineering design in MOW217, and you will use the textbook in 4 other modules. This is now for the mechanical engineering students during the course of your undergrad studies. Be that as it may, in the States they use the hard cover. In South Africa the soft cover is more common, but what you see on the screen here is a photograph of the hard cover that's being weighed. It weighs 4 pounds and 4.5 ounces, which equates to just less than 2 kilograms. So that's where the name Shigley comes from. Now, what is the hauler part? Now, they divide their class into teams, and each team gets issued with a small electric motor and a set of plastic spur gears that you see on the screen at the moment. Alright, and each team then has to design, manufacture and assemble a gearbox using that motor and those small gears. And on the day of the competition, the teams bring their gearboxes, and the gearboxes get clamped to the top of a wooden platform that you see on the screen schematically on the screen at the moment. This wooden platform has 4 tracks, so it can accommodate 4 gearboxes simultaneously. The length of the platform is about 3 feet, so it's approximately 1 meter or 1000 millimeters, and the width is 12 inches. Now that's approximately 360 millimeters, but you can do the conversion to get the exact number. That doesn't matter. The point is that there are 4 tracks here, and this wooden platform can also be inclined at different angles. Now, why is that needed? Okay, let me just quickly scroll down this paper. There's a photograph of one of the manufactured and assembled gearboxes here. There you can see it. Those spur gears are now all secured to shafts. There's the small electric motor. Here is a clamp to clamp the gearbox to the top of the wooden platform that you can only see the top of the wooden platform in this photograph. And then also in this gearbox there's a pulley with a fishing line. As the motor rotates and the gears are driven, this pulley rotates and it winds the fishing line onto the pulley. Okay, so at the bottom of the ramp, that's where there are trolleys loaded with Shigley textbooks. Okay, and here you can see the fishing lines attached to the trolleys. So when the lecturer says go, he pushes the stopwatch button and the Shigley gearboxes, or the gearboxes, wind the fishing line onto the pulley, and as that happens, the trolley gets pulled up the ramp. Okay, and obviously then they compete. The fastest time to pull up the trolley up the ramp is obviously the winner. Now what they do to make it interesting is they load a single, they start with a single Shigley textbook and they incline the profile or the platform at 20 degrees and then take time measurements on how quickly you can get the single Shigley up the ramp. Okay, and then they incline the ramp at 30 degrees and they load the trolley with 2 Shigleys and do the same. They repeat the exercise with the ramp inclined at 40 degrees with 4 Shigley textbooks and finally at 60 degrees with 5 Shigley textbooks. And these teams with no entries, their gearbox obviously didn't succeed in pulling up the load up the ramp. Okay. Now that's in the US. They've got smaller classes from what I understand, specifically at Davis. And so they have the means to train the students on how to use the machinery in their workshop. And so the students are well trained and they can manufacture their designs, assemble it and test it, etc. Okay, that's it in the US. So what I envisage for the future is to issue each and every MOW 217 student with a kit consisting of all the manufactured parts, the gears, everything, all the nuts and bolts, everything to assemble this Shigley gearbox that you see on the screen here. That's the vision for the future. Now for this year, we will in our practicums create or dimension the detailed mechanical drawings of approximately 10 of the components that go into this gearbox. Okay, and we've already started with practicum 3 where we dimensioned the base profile that you can see on the screen. Stage 1 of the base profile, I must add, and we also dimensioned the side profile. There are 2 of them, 2 identical side profiles with the slot machined in both. Obviously they are identical. That we started with in practicum 3. Now in practicum 4 we will do stage 2 of the base profile, and I'll say more about the details of that in a separate video. And we will also dimension this side plate in practicum 4, but I'll say more about that in a separate video. Okay, what I would like to do now is just give you a rundown of how this gearbox actually works. Okay, so you will recognize hopefully this small electric motor. It's connected to a drive shaft with a special arrangement, and we'll say more about this connection in a future video. But as the electric motor rotates, the drive shaft will rotate. And if I can just quickly hide this top cover plate. Okay, so this view is not bad. Okay, so there's a pinion gear, a small gear attached to the shaft, and obviously as the shaft rotates, the gear will rotate, and the gear is meshed with this larger gear. So the larger gear will rotate. It's connected to a shaft, and as that shaft rotates, there's a second pinion gear that rotates, which meshes with another large gear, and finally this shaft over here is rotating, and what you see here is a hole that goes all the way through this shaft. That's where the fishing line is attached. The fishing line is then guided through the slot. Okay, and this gearbox is as with the gearbox in the States. It's attached to the top of the frame, okay, which is inclined, At the bottom of the frame, there's a trolley with a Shigley textbook, one or more Shigley textbooks loaded on top of the trolley. And so as the gearbox when the gearbox is switched on, all the shafts rotate, and the fishing line that's attached here, it goes through the hole. It's with a knot, it's tied securely, so the fishing line will wind onto this shaft and it will pull the trolley with the Shigleys up the ramp. Okay, what this round component is simply a deflector to prevent the fishing line from ending up in the gears or onto those nuts. Okay, so that's all that is. That's the idea of that. Now, okay, I'm not showing any of the details of how this gearbox is attached to the top of the frame. As a matter of fact, that is going to be your individual assignment. You will design the component or components needed to attach the gearbox to the top of the frame. But I'll give you more detail on that just after the engineering test week. Okay, you are also, for the individual assignment, allowed to make modifications to the gearbox to a limited extent. Okay, you cannot redesign the complete gearbox, but to interface with whatever component you design or decide to design, you are welcome to make changes to the gearbox. All right. Now, okay, so we've talked now about the base profile and the side profiles. Okay, so the other important, very important aspect of this gearbox is the side plate. Okay, well, there are actually two side plates, this plate and the other one, and they aren't identical. They differ from each other. There's a side plate left and a side plate right that we will have to manufacture. Okay, but yeah, and what is important for those two side plates, when we assemble them, when we assemble the gearbox, is the side plates need to be aligned relative to each other. So the question is, how do I intend on ensuring good alignment between side plate left and side plate right? And what I do is, for the base profile stage 2, we will implement dowels. Okay, and dowels running through the base profile. And then for the side plate left and side plate right, we've got a hole, precision hole, that slides onto the dowel on one side, and on the other side we've got a slot, that also a precision slot that fits onto the dowel. It slides over the dowel when we assemble this gearbox. Okay, and we've got exactly the same arrangement on the other side. Let me quickly show you. Okay, so for this side plate, there's also a hole corresponding to the hole on the opposite side plate, as well as a slot corresponding to the slot on the opposite side. Okay, so that's how we get good alignment. So now it follows then obviously that the position of the dowel hole, this dowel hole and slot in the side plate, as well as the position of the round holes into which the bearings fit, those positions are all very important. Okay, they can't have loose tolerances. There we must specify good accuracy positional tolerances. Right, that's the one thing that's very important, and I think it goes without saying. The reason why we want good alignment is when this gearbox is assembled, there will be bearings in both side plates, and the shafts will fit into the bearings. All those fits are good accuracy fits. And so if there isn't good alignment between the hole in the left and the hole in the right side plates, that bearing, this shaft will be skew and the gearbox will get jammed. It will not work. Okay, so we obviously also want good positional placement of the three shafts relative to each other, because these gears need to mesh. Okay, so but more important than the distance between, well, it's actually the same importance, because we want good alignment between the bearing holes on both plates. Okay, and that bearing hole is need to be dimensioned relative to datums, just like the slot and the dowel hole also need to be dimensioned relative to the same datums and constrained by positional tolerances. All right. So that gives you a good idea. I will give further details in a subsequent video on the specific features related to Practicum 4, as well as Practicum, the remaining Practicums. I will for each Practicum give specifics in a separate video. But I do hope that this video gave you an overview of the gearbox. I'm sure it does. And with that, I would like to thank you for watching the video. Thank you very much.